flood basalt unzip across the landscape, until several miles, then tens of miles, and finally a near straight line more than 100 miles in length was all simultaneously erupting. In mere days, an area of 50 square miles had already been covered in lava, and this figure only continued to expand, increasing by about 7.7 square miles every day. As the eruption continued at a rate of 15,000 cubic meters per second, the flood of fluid lavas began reaching the edge of the large and deep valley, slowly filling it. This eruption would continue for the next 6 years until an area the size of New Jersey was buried by an average of 412 feet thick of fresh lava. In total, approximately 2,838 cubic kilometers or 680.9 cubic miles of lava was erupted in this short timespan, occurring alongside the release of an estimated 3.7 billion tons of sulfur dioxide gas. Because End-Ediacaran extinction, so much sulfur dioxide was released, causing the amount in the atmosphere to spike by more than 700%. It blocked large amounts of sunlight, perhaps upwards of 30%. This caused a volcanic winter to fall across the planet for the next 10 years, causing hardship for the ancient Ediacaran fauna present in the adjacent oceans. But then, the climactic implications of the 25 billion tons of released carbon dioxide took over, causing a rapid warming of the planet by 8 degrees Celsius or 14.4 degrees Fahrenheit, which would remain for thousands, perhaps even tens of thousands of years. With many of the weirdly shaped Ediacaran fauna, which represented the world's first large-scale multicellular lifeforms, having already suffered greatly reduced populations due to the prior cold snap, a further bottleneck in population occurred as the planet greatly warmed. This was owed due to warmer water holding less oxygen, making ancient animals unable to breathe in this environment. Across the next 5 million years, this process would repeat at least another 100 times, wiping out 80% of all animals in an event known as the End-Ediacaran Mass Extinction. But why did this event occur in the first place? Well, during the late Ediacaran period, a third southern Oklahoma olicogen arm of a developing triple began to form, cutting across swaths of modern Oklahoma and Texas in what is known as the southern Oklahoma olicogen. The two prior arms to the south had originally helped break apart a Cryogenian period supercontinent, and by the Ediacaran period had been infilled with the Iapetus Ocean. While a hotspot link has not been definitively proven, I am of the opinion that a large mantle plume initially triggered the third arm to begin rifting, thus being the source of large amounts of molten rock that would subsequently intrude into the crust and erupt. While this rift would eventually fail, it served as a path of least resistance for large amounts of molten rock to erupt into, as it still spread apart for some time. Today, a limited extent of igneous rock from this ancient cataclysm can be found on the surface as granite in the Arbuckle Mountains and more widespread granite marking the highest points in the Wichita Mountains. But wait, I was just talking about a flood basalt province, so how would this granite be related? Simply put, not all of the tremendous volumes of molten rock which intruded into the crust long ago erupted onto the surface, meaning those that didn't experience fractional crystallization, eventually becoming rhyolitic. Rhyolite and granite. This material then either erupted as rhyolite or solidified underground as granite. When this material was uplifted during two subsequent orogenies, it formed a harder core which would remain as numerous softer sedimentary rock overlying it eroded away. And this is why this ancient late Ediacaran and early Cambrian granite today forms modern high points